So we're going to look at confidence intervals again a little bit more today. We're going to look at margin of error and how do I want to, if I want to get a specific margin of error, how do I do that? And then we're also going to introduce inference, and we're going to do a little activity with conversation hearts. It's around Valentine's Day. I do this activity usually every year, and well, we're behind because of all the snow we've had, so that's okay. Anyway, let's go ahead and look at this example first. We have an AP article. What does AP stand for? Not advanced placement, but in this case it's what? You even know what I'm talking about? Like the news thing? AP? Really? Like, huh? Adrian Peterson. No. I'm trying to remember myself what it stands for, but it's like it's a news feed. Like come on, someone tell me. What is it? Thank you. It's a poll. I'm losing my. Gallup. It's kind of Gallup is something different. We're gonna actually look at Gallup in a minute. Gallup is actually is a polling service, but yeah. All right. AP. Thank you. Associated Press was driving me crazy. Associated Press. I was like, it's on the tip of my tongue. I'm like, come on, it's a news thing. Okay. Okay, Associated Press. Okay, it's a trusted news media source, okay? So they have an article on a potential violence in the workplace. It's kind of scary, violence in the workplace, right? You've heard of going postal and things like that. So 750 full-time workers, okay? And this is obviously the link or the information for the article itself. Of those surveyed, 125 indicated that they were so angered by a coworker during the last year, they felt like hitting the person, but they didn't. That's scary, right? So let's stop there for a minute, because we're given a couple of different numbers. We're given a 750 and we're given a 125. What do those numbers represent? One's a sample size. Which one is that? Okay, so as you're reading a problem, it's always good to kind of identify some things. So our sample size is 750, I agree. What else are we told? What's the 125 represent? It's the part of the proportion. The p hat is going to be 125 over 750. Very good, okay? That's what our sample proportion is. Good. And it says that, let's keep going then. Assuming it's reasonable to regard this as a random sample, so we're kind of just assuming that it's met that first condition. We'll have to check the other two. Let's construct a 90% confidence interval for the true proportion of workers who have been so angered they want to hit a coworker. Okay, if we're looking at a 90% confidence interval, can someone tell me what that has to do with anything? Let's see if we remember from a week ago. What is 90% confident? It's tied very closely to one thing. Do you remember what it is, Isaiah? Our Z star. So let's remind ourselves the formula for a confidence interval for proportions. It's your statistic plus or minus your margin of error, which consists of the Z star times the standard error of p hat. Do you agree? Okay. So the 90% confidence interval is very much attached to our Z star. Okay? So let's fill in some information that we know. Before we can find our standard error, what do we always need to check for? It's like I hear crickets. What do I need to check for? Conditions. All right, so the first one is always the random condition, and we're told in the problem that what? That we have to assume random, right? So we're going to assume random. The problem tells us to do that. What's the next condition? %. What is that 10% thing? The sample size. So in our context, we're going to say what? 750, good. Of all workers, good. Full-time workers, is it specific to that? Yes, good. Is less than 10% of full-time workers. agreed? What's the third condition? The nearly normal, which we have to check for NP is greater than 10 and NQ is greater than 10. So we're going to say, I actually like just to kind of write it so that I know what I'm looking for. Oops, not P, that should be a Q, right? Good. All right, so N is 750. Are we given a P? Are we given a claim as a proportion? This is the proportion of people who want to hit their coworkers. I don't think we're given one, right? So if we're not given one, what do we have to assume in its place? What are we going to use in its place of P? The P hat, okay? So if you always use P if you're given it, but if not, we'll use the P hat, okay? So we're going to say, and then we have 125 over 750. Is 125 greater than 750? I'm sorry, is 125 greater than 10? Yes, okay. And then we have our next one, which is NQ. So what would Q be? 625, yep, over 750. And we know that 625 is also greater than 10. So all of our conditions have been met. Good, yes. Q is the complement of P. Okay, sure. Okay, next question. Again, Q is the complement of P. So if this is P hat, Q hat is just going to be 625 over 750 because 125 plus 625 is 750. Okay, good. All right, so I've met my conditions. Awesome, we always need to check those. And then our next step is going to be to use the formula for standard error. So let's do that real quick. So our standard error, what is that formula? Square root of PQ over N. We don't have P, so we're going to use P hat. So we're going to say 125 over 750 times 625 over 750 all over 750. And it's a square root of all of that, correct? PQ over N, or P hat Q hat over N. So let's go ahead and reduce that, and let's tell me what approximately the standard error is. So 0.0136 approximately. Okay. Now some people might say, can I round that to 0.014? Sure. But I think in this case, 0.0136 kind of makes a little bit more sense just because it's not as rounded. But it's kind of an ever field. AP is not real. No, AP meaning the advanced placement program in this case, is not super picky about rounding. Okay, as long as you show your steps and show your work, they're okay with it. Okay, so now we're going to go ahead and just create our confidence interval. So we know, again, our formula is P hat plus or minus Z star times the standard error of P hat. And again, what you're adding or subtracting is your margin of error. P hat was 125 over 750 plus or minus, and then we're just going to kind of plug in our numbers. The standard error we found to be 0.0136. How do I find Z star? We did this last class. You remember, Amanda? That's okay. So what are you going to do? Oh, what were you going to do? Okay, that's all right. Right. So inverse norm in this case, what are you actually finding the percent? 0.9, not 9, not 90, but 0.95, because you're including one of the tails, right? So inverse norm 0.95. And again, this is one that often we should know because it comes up quite so often, 90%, 95%. But it's a good idea to, I know, I was on the wrong one. Really? Sorry. It's a good idea to keep this practice in mind because I know for certain that on a future quiz or test, I'm going to ask you what Z star is associated with some odd percentage, like a 92% confidence interval or a 97% confidence interval. So it's important to know the ones that are common, but do we know how to find one that maybe wouldn't be so common? Okay, did you have a question, Isaiah? Did I? Okay. So inverse norm, and then we're going to say 0.95. Because it's a Z value, we're going to leave our mean and standard deviation as 0 and 1. And we should get 1.645. Okay? So 1.645 is going to be the Z star that's associated with 90% confidence. And again, if I was more confident, 95% confident, doesn't your Z star value increase? Is it 1.96, the Z star that's associated with 95%? So it's a bigger number, which means my margin of error is going to increase, which means my confidence interval is going to get wider, right? Okay. So let's find our margin of error first. So 1.645 times, I'm going to go ahead and I'm going to do exactly, so it's not rounded in my calculator. Do you know how to go up and capture values on your calculator so you're not rounding? All right, so go ahead and look at what I did, Sammy. Do you see how I have 0.0136 up there on my calculator, and then I found the unrounded one? If I just hit times, it uses the most recent answer, and if you arrow up on the calculator, you can capture things previous to it. And since I wanted to capture the 0.013, I hit enter when I got there, and it should just produce it. So that way you're not rounding anything, okay? So at this point, the margin of error that I got was 0.0224. Okay, that's probably a good place to round. And then we have 125 over 750. And again, I'm not putting a decimal with that one quite yet. Now AP, again, advanced placement, not the. Thank you. Why can't I remember that? Likes to give confidence intervals that look like this sometimes, leaving it like this with your statistic plus or minus your margin of error. You will often see confidence intervals written that way. Okay, so I want you to be able to recognize that's what that is. It's actually a confidence interval. But sometimes we can also go ahead and write the interval itself. So we're going to take 125 over 750 plus or minus the margin of error. So plus the margin of error. So the upper bound of my interval is 0.189. And then the lower end of my interval, no, because it's the higher end. You're going to add, it gets bigger. You subtract, it gets smaller, right? Okay, oops. And then we subtract and we get 0.144. Good enough. Now, do I leave it like this or do I put it in percent form? I'm okay with either actually, but as long as you tell me that one's a percent and the other is not, either of those is okay. Okay? So, what am I always going to ask you to do if I give you a confidence interval? What did I say that I wanted you to do each time? Put it in context. So what is the context? What does this mean? So let's go back up to the context for a minute. So what is that interval saying? I'm 90% confident that. So we always want to start with that, right? So I am 90% confident that. Someone was saying it. That what? The true proportion. Because we don't really know what the actual percentage of people that want to hit their coworkers is, do we? I'm not sure we could ever really find that. But well, who knows if they'd even be honest or whatever. But we're pretty confident that the true proportion of people that want to hit their coworkers is between, we probably should, you know, either way we can use either one. I'm going to say 14.4% and 18.9%. Okay? Tanner, how'd you do with that? You okay? So can we find our Z star Can we check our conditions? Do we know what a margin of error is? All different types of questions. Can we interpret it correctly? Okay? How you guys feel? Nathan? Okay? It's making me nervous. Okay. I like it when y'all are quiet. Okay. Let's look at on the calculator. Because guess what? The calculator does it for you. You're welcome. You're welcome. You're welcome. You ready? Now, the calculator does do it for you, okay? Now, here's the problem. I am okay with you giving me the answer, but what else am I going to be looking for? The work. I'm going to be looking that you checked your conditions. I'm going to be looking that you found your standard error. You've got to do that, don't you? So that's okay, but it's a great way to check your answer, don't you think? It's a great way. So let me show you how to do that. I'm going to pull it up on the smartboard so those of you who are watching the recording can actually see how to do it. But you're going to go on the, let me pull it up first. So on the calculator, here we are, you're going to go to the tests. So let me go ahead and figure out where this is. Judith, would you turn the lights out so we can kind of see this a little bit better? There we go. All right, you're going to go to Stat and over to Tests. Okay? And this is going to be a nice section of the calculator that you're going to want to do and use quite a bit. Okay, so let me write these steps down as we go through it. Okay, so on the calculator, you're going to go to Stat and then over to Tests. Now, if you scroll down, you will see a lot of tests. Okay, and we're actually going to learn by the end of our inference unit almost all of them. Okay, and believe it or not, the hard part at the end is going to be to know when to use which one. Okay, each individual test on its own is really not hard. Once you know the steps in the process, which I'm going to teach you today, it's really not that bad because it's the same almost every time. Conditions might change a little bit, formulas might change a little bit, but you have a formula sheet, so it's really not bad. So let's think about, scroll through some of the names. Actually, yeah, the name's not on here. Scroll through some of the names and maybe look and see if you find one that makes sense in this case. So if we kind of scroll through, we don't know anything about tests yet. All we know about is intervals, correct? So let's scroll down. And do we see an interval one that maybe makes sense? Well, I actually think we have a proportion, don't you? Don't we have one proportion? One proportion z interval is actually what we're going to be using here. Okay? And if you maybe choose the wrong one, the good news is that the calculator asks you questions. And if you don't have all the information, then you know you've chosen the wrong one. But here we're going to use the one proportion z interval. Okay? So if we go ahead and hit enter, it's going to ask us to input some information. X over n is p hat. Okay? So x in this case would be 125, and n would be 750. Okay? Because x over n is our p hat. And our confidence level was 90% in this case, wasn't it? Weren't we 90% confident? Are those numbers correct? Double check me. Okay. 0.9. Yeah, 0.9. That's our, because of 90%. Okay? And then we'll go ahead and hit calculate, and it's the same thing we got. 14.4 and 18.9. So we knew we did it right. Whoop, whoop. That's what we got, right? We did it by hand? Calculator's pretty. It's so nice. I love it. It's so nice. That's not bad, right? It's kind of nice. You can check your work. But you are going to have to check your conditions. You're going to find your standard error by hand. There are some things you're going to have to do by hand, okay? Now, I'm always going to teach you the long way first, especially when it comes to hypothesis testing, which we're going to start here in a little bit. But your calculator is a great backup to check to make sure that you're doing it right. Okay? Good. All right. So here's a different type of question. Okay? Don't we really want to reduce our margin of error as much as possible? Think about it for a minute. Let's kind of take a step back. If I want to create a confidence interval, don't I really want it to be as narrow as possible? I don't want it to be really wide. It doesn't make any sense if I say, well, between 0 and 100% of people are going to pass AP statistics. Well, sure, of course, right? That makes, yeah. But we want to make it as narrow as possible. So how can we reduce that margin of error? There are a couple of different ways, okay? One of them is going to be to lower the confidence level, and we know that. The less confidence we are, the smaller our Z star is going to be, which means our margin of error will decrease. The other is going to be to increase our sample size. Now, why would that have any effect on it? Cal, put your phone away, baby.
Because you're dividing by n.
Yeah, because in your standard error, aren't I dividing by n? Right? And isn't that part of the formula? So if I increase that number, isn't my standard error going to be smaller? So those are the two ways to decrease it. So let's look at this example. And this is a good example. It's going to show up on a test or a quiz in the future, so you should definitely write it down. I would star it, I would highlight it, I would circle it with a highlighter, put a sticker by it, kiss it with lipstick, I don't know, tape a chocolate next to it, something to remember. Guaranteed something like it's on your next quiz or test. So what have I given you? 2 questions you can guarantee to see on your next quiz or test already, haven't I? Find the Z-star that's associated with a strange confidence level. And 2, finding a sample size that's needed for a specific.
Can we find the strange one? Do we have to show
Yes, you have to show, yeah. Exactly like I just did. And show me that you did inverse norm and whatever. Yep. Okay. Yes. Yeah. The math or the picture is okay. I'm just a visual person, so I always do that. But if you're not, that's okay. All right. So this is a good question to look at because eventually you're going to be collecting your own data after the AP exam. And some of you may choose to do polling, like a Gallup poll does polling. We might do some polling. So what if we know we want to do a pretty good confidence level, 95% confidence, but I want a margin, I know specifically what kind of a margin of error I want. Think back to November when all of the voting precincts were out and all of the commercials and they were trying to estimate who was going to win what office, and they would show that. Do you ever remember underneath it would say margin of error plus or minus 5% or something like that? So they're they know ahead of time really what margin of error we want. Okay? I don't want it to be very off. I want it to be pretty small. So because of that, I know how big of a sample size I need to collect, and that's what we're doing here. Okay? So let's think about something. We know what margin of error we want, correct? So what's the formula for margin of error? Let's write that down. The margin of error formula is what? We just did it. Z star times standard error of p hat. Good. Okay? So we know we want the margin of error to be 2%, so 0.02. We're about to get pretty mathy, okay? We need some good algebra skills to come up into this place. All right? Let's do it. Okay? What Z star is associated with 95%? 1.96. If you don't remember, it's inverse norm 0.975. Whoa. Where'd 975 come from? Middle of 95%, and then one of the tails. Okay? All right, so we know it's 1.96. Well, I don't know the standard error. What's the formula for standard error? Let's write it over here for a minute. So we're actually trying to find this, right? We want the sample size. All right. But I don't know P or Q either, do I? If you're trying to estimate P or Q, what value for P doesn't give you any kind of special treatment in one direction or the other? Well, that's one. One is it's always true. Which percentage is not going to give any preferential treatment to one answer or the other? 0.5, 50%. Would you agree? Right in the middle. So we're going to use 0.5 for both P and Q here, okay? Because that's not going to influence our decision in any direction. Fair enough? All right, so let me put that in there. So we're going to say 0.5, 0.5, and then we're going to solve for n. So I have an equation. As a matter of fact, I have a radical equation where I need to solve for n. So we need to think we need some mad algebra skills, Nathan. I don't know who your algebra teacher was, but maybe it was me. Let's go. What should we do? You don't remember? All right. So we need to solve for n. We need to get who was your algebra teacher? Give me up top. Come on. Yeah. So I taught a lot of y'all algebra. That's kind of weird. Okay. Anyway, we need here. I've got other things with it that I need to get rid of it. I need to isolate this radical. So what's with it right now that I got to get rid of? So I got to divide by 1.96. Would you agree with that part? So let's take 0.02 and divide by 1.96. So 0.01. And here's a clue. Don't ever round. So let's leave values on our calculator. Now, obviously, I'm going to round by writing it down. Okay? So I'm going to literally write 0.0102 over here. But I'm going to leave that value stored in my calculator because I don't want to round it to the very, very end. Because if you start rounding early on, it's going to affect your sample size by 1, 2, or 3. And I have seen on previous AP exams where they give you answer choices that are only one apart. Okay? So it's not. But I'm just saying I have seen on some of the release questions. So you just don't want to round to the end, okay? It makes a difference. So is it okay if I multiply 0.5 times 0.5? So I get 0.25 up there? Any questions so far? Come on, Sammy, say it loud. I'm going to square both sides now. When I square both sides, don't I get rid of the radical? Okay, so that's what we're going to do. So I'm going to square this side. And I'm going to square this side. So on the right-hand side, what I have left is simply 0.25 divided by n. On the left-hand side, I'm going to leave the value that's already stored in my calculator and just hit x squared, and it will square the most recent answer that's stored there, and I get some crazy number. That's okay. So I'm going to say, by the way, that E does mean time. It's the scientific notation, so I'm just going to write it with 4 decimal places. So 104. 1, 2, 3, 4. Oh, too many zeros. Too many zeros. There we go. Does that look right? Okay. How am I going to solve this for n? And then divide by. So is it okay if I just write it this way? Now, I did 2 steps at once there. But Hunter, if you want to divide it into 2, that's perfectly, that's what you're doing. I'm going to show you the long way around just for a second. He went ahead and multiplied both sides by n to get this to cancel, and then divided by this number to get n by itself. He did it in 2 steps. No. I did it in 1 step, but it's okay if you want to do it in 2. I simply know that if I'm dividing by a variable, that I can switch these 2 things around. It's the same thing. So again, I have a stored value on my calculator. So I have 0.25 divided by, I'm going to go up and capture using my arrow button, the non-rounded answer. And what do I get? 401. 1. So in order to get a margin of error within 2%, I know that I need to ask this many people. Yes. Oh, yeah. Well, all this means is that, this is great. Sample sizes, but the way things are collected matters. There's going to be sampling errors, and for that we can't account for all of those things. That's all that means. Okay, and people might not respond. Under coverage, we might ask it might be a man on the street kind of question. I'm going to ask 2,000 people at whatever is convenient for me. That we can't account for. In a perfect world, we would randomly sample accurately 2,401 people. That goes back to a question that Amanda brought up, the Gallup poll. You ever get called on your phone to answer surveys? They irritate me so much. I hang up on them all the time. Don't bother me. I'm at home. So there's a lot of bias involved in that, right? So, okay. So, do you think you feel pretty confident about that? It will come up again. So let's go back and remember your margin of error formula, plug in your percentage, plug in the z-star. It's got to tell you a level of confidence. Why did I use 0.5 again? Because it's the middle. Now, if I'm given a P, you have to use it. Okay? If you're given a claim, like you're given that their true percentage is this, then you have to use it. Okay? But if not, you can estimate to the best so it doesn't give anyone an advantage, the 0.5 there. Okay. Want to have some candy hearts? I do. All right. So what I'd like us all to do is I'm going to ask if, Charles, would you hand everybody a napkin? And I'm going to give everybody a little sample. You can sit at the table for me. And give everybody a sample of candy hearts. So I'm going to give everybody a sample, and I want you to, based on your sample, create a 95% confidence interval. Okay? Good? In this case, everyone's going to have a different sample size, right? We want to find the proportion of candy hearts that are pink, because we think that there's too many pink ones. And I like yellow. Okay? So we're all going to create a different confidence interval. So do me that favor. I want you to find everyone's going to have a different p-hat. Would you agree? The p-hat that you're calculating is going to be the pink out of the total. So go ahead and tell me what your p-hat is. And we already know that our z-star is going to be 1.96, don't we? All right, so everybody go ahead and do that. If you would, on this board, come up and write what your confidence interval is for pink, the proportion of pink candy hearts. Okay, so Kyle brought to our attention that we really didn't meet the condition, the third condition in this case. We are assuming it was a random sample. I literally poured them out of a bag, right, and mixed them up, whatever. It wasn't like I picked one that had more pink or not. It was randomly chosen. So we read the random condition. I think our sample size was less than 10% of all pink candy hearts. And then the last condition is the one we have to be careful about. Our sample size, in most cases, probably didn't meet the NP greater than 10 and Q greater than 10. Do you agree? And that happens. In some cases it might have, some cases it might not have. I'm not sure. So we may or may not have met the third condition, so we'll proceed with caution. But do the intervals surprise you? Yes or no? Are they near what we would expect? They're wide. I agree, they're wide. Do we expect them to be wide? I do. Why? Because I'm pretty confident, right? So since I'm pretty confident, I do expect a relatively wide. Now, what in context does that mean? I don't know. It depends on our sample size. It depends on a lot of things, right? We had a fairly small sample size in each of our cases here, which means that our margin of error, because it was a small sample size, our margin of error is probably going to be pretty big, right? And that happened in each of these cases. All right, so let's take these. These are actually pretty good. And let's look at the claim. Okay? We really think there is an overwhelming number of pink candy. Well, in our case, probably an underwhelming number of pink candy choices. So maybe I should change that wording. So in this case, we'll say underwhelming. We don't think there's that many pinks. It seems like there's fewer pinks maybe than any of the other colors almost in this case. Don't you agree? So let's make it in context of our situation. Okay? Let's say the manufacturer claims that 10% of the candy hearts are pink. Do we have evidence to suggest that they're correct or that they're incorrect? And by the way, our confidence interval is evidence. So let's go back. So let's think about this. So they claim 10%. Let's go back and look at all of our confidence intervals. What does 10% have to do with any of these intervals? We're looking for it to be captured by our interval, right? So we're looking to capture the claim. And we did in every single one of our cases. So we were actually 100% confident in this case. But 95% of the time, when we do our candy heart, I mean, if we had, each person had their own or whatever, and we had 100 people that did it, 95 out of those 100 would capture 10%. Does that make sense what I'm saying? Okay. Now, so when we have a confidence interval, we're looking to capture the claim. So yes, we have evidence. And to answer this question with our confidence interval only, we would say yes, the confidence intervals capture 10%. Which means what in context? Is the manufacturer's claim correct, or is the manufacturer's claim incorrect? It's correct. Okay? We have no evidence to overturn. We can't sue Brock's because they lied to us, right? None of that stuff, because our confidence interval captured their claim, so we don't really have any evidence to overturn it. Fair enough? Okay, good. So therefore, the manufacturer's claim, I'm sorry? What did I say? Did I say something wrong? No? Okay. The manufacturer's claim is correct. Helps if I can't spell. I'm giving y'all sugar and sending you out. Okay. Now, my goal today, because of our delayed opening, we don't really have time to continue, but at least I want to give you the steps of our next venture, okay? And that is hypothesis testing. So what we're going to do is, if we want more convincing evidence, confidence interval is some evidence, okay? But we want more convincing evidence to support the claim of the manufacturer. We're going to need to do something called a hypothesis test. And the hypothesis test we would do here would be a one proportion, not Z interval anymore, but a one proportion Z test. And we'll talk more about this next class. But for every single hypothesis test that exists, there's the same number of steps. And I do want you to write those down for me so that next class when we come in, you know what those steps are. And there's 5 of them, okay? And no matter what kind of hypothesis test, these 5 steps are going to be true, okay? So take a second and write those down. These 5 steps are the same for any hypothesis test at all, okay? So this is important because we're going to be doing hypothesis testing for the remainder of the year. So you need to identify these 5 steps in your brain always and forever. Now, the hypotheses might change. The conditions might change from test to test. The test statistic might change. We'll talk about what each of those things are. But the 5 steps, always, yes, Hunter. I would write everything you see down, yes. Okay? So next class, I'm going to talk a little bit more in detail, a lot more in detail, about what is meant by hypotheses. What is that H-O, whatever that is, okay? We're going to sing a song to it. It's going to be fun, okay? What does that mean? conditions right now, we know what conditions we're talking about. For proportions, we have conditions for means. Remember, we had the two branches back in our head early on? Okay, so we know what conditions we're looking at right now. What's a test statistic? I'm going to explain what that is. In this case, it's going to be a z-score because we're talking about proportions. We're talking about a z-test. And then we'll talk more about what a p-value is. Not p-hat, not a p-value. It's actually, I kind of alluded to this a couple of weeks ago. It's a probability that the sample we got happens by chance. Okay? So we'll talk more about that tomorrow, our next class. And then a conclusion and context always. Okay? All right. If you would, do me a favor and keep your candy heart information, your statistics. Keep this interval and your calculations for that somewhere handy so that you have it next class. And we're going to take that same data and do a hypothesis test with it on Wednesday. Okay? Yes. And let me go ahead, let me go ahead and write your homework down as well. It still will be with chapter 19, a lot of finding what size intervals we need, that kind of thing. And I'll write it up here in red. All right, there you go, guys. Okay, chapter 19, 24 through 38 even is your homework.